Hi students, today we are going to learn the theorem of basic proportionality. We call it as the basic proportionality theorem. In short, we call it as the BPT. This theorem is very important from the exam point of view and also to solve further exercise. In this theorem, we are going to use the properties of ratios of areas of two triangles, which we have seen in our last lecture. So please, if you have not seen that, then go through it and then you understand this theorem. Here, if a line parallel to a side, we are starting with the theorem, if a line parallel to a side of a triangle intersects the remaining sides in two distinct points, then the line divides the sides in the same proportion. Here you can see in triangle ABC, line L is parallel to side BC and it intersects the side AB in point P and AC in point Q. आप देख रहे हो लाइन L AB को पॉइंट P में इंटरसेक्ट कर रही है और लाइन L साइड AC को पॉइंट Q में इंटरसेक्ट कर रही है. And this line L is parallel to BC also. This is given. Now what we have to prove? So it divides the sides in the same proportion. Here we have to prove that side AP upon side PB is equal to side AQ upon side QC. Now construction. To prove this theorem, here we have to use the construction. Draw segment PC and segment BQ. Because of this segment PC and BQ, we get two triangles, triangle PQB and triangle PQC. Now we have to see the proof. Triangle APQ and triangle PBQ have equal heights. Triangle APQ and triangle PBQ. If you see from here, then you will understand that side PQ is the height and these two triangles have common heights, that is PQ. The same part I have taken here for your understanding purpose. If you see the triangle from here, then you will get it triangle APQ and triangle PBQ. In this triangle, the heights are common and that is PQ. So their ratios depends upon their bases. So area of triangle APQ upon area of triangle PQB is equal to AP upon PB. Similarly, if you see from here, okay, then again we will get the two triangles, that is triangle APQ and triangle PQC, which I have drawn here for understanding purpose. In this triangle we have to see from here. So this is the height and these are the bases. So triangle APQ and triangle PQC में आप देख सकते हो PQ is the common height, okay, and so their ratios are depends upon the bases. So उनके जो area का ratio है वो किस पे depend करेगा? Bases पे. So here AQ upon QC, areas proportionate to bases. So for both first and second point, here we have a same reason, areas proportionate to bases. Now segment PQ, you can see segment PQ is common base of triangle PQB and triangle PQC. So triangle PQB में और triangle PQC का ये दोनों triangle में आप ध्यान से देखोगे तो PQ is a common and that we consider as base. So that is a common base and segment PQ is parallel to segment BC. Segment PQ, that is your line L, segment PQ is parallel to segment BC. Hence, triangle PQB and triangle PQC have equal heights. Always remember, in two parallel lines, in any two parallel lines, if there are n number of triangles, they all have equal heights. Here you can find there are two triangles which we consider, triangle PQB and triangle PQC. They both lies between the two parallel lines, that is line PQ and line BC. Line PQ you can call it as line L also. तो ये जो दोनों ट्रायंगल्स है, इन दोनों ट्रायंगल्स की हाइट क्या होगी? इक्वल. दैट्स आई हैव शोन हियर इन द थर्ड पार्ट. थर्ड पार्ट में आप यहाँ पे देख रहे हो ट्रायंगल PQB एंड ट्रायंगल PQC. इन दोनों ट्रायंगल्स का बेस होगा PQ और जो इनकी हाइट होगी वो इक्वल होगी. व्हाई इट इज इक्वल? बिकॉज दे लाइज बिटवीन PQ एंड BC. सो यहाँ पे जब दोनों ट्रायंगल्स के हाइट इक्वल है और दोनों के बेस इक्वल है तो फिर यहां पे दोनों के एरियाज भी क्या होंगे? इक्वल. सो एरिया ऑफ ट्रायंगल PQB इज इक्वल टू एरिया ऑफ ट्रायंगल PQC. दिस इज व्हाट वी गॉट द थर्ड स्टेटमेंट. नाउ इफ यू कैन अंडरस्टैंड दिस, वी कैन टेक दिस हियर, area of triangle APQ upon area of triangle PQB, then area of triangle APQ upon area of triangle PQC. This both we are showing it as equal. Why? Because from 1, 2 and 3. If you notice, the common part numerator is equal but denominator is different. But here in the third statement we have proved that PQB, area of triangle PQB is equal to area of triangle PQC. So this part is equal. So numerator दोनों में common था, denominator हमने यहाँ पे third statement में prove किया. That's why we can say that area of triangle APQ upon area of triangle PQB is equal to area of triangle APQ upon area of triangle PQC. Now, if these two are equal, that means left side is equal, then right side must be equal. So we can say that AP upon PB is equal to AQ upon QC. So here from 1 and 2 we got this reason. AP upon PB is equal to AQ upon QC, the thing which we want to prove. So यही हमें prove करना था. सो यहाँ पे आपको सिंपल वे से समझना है, जब भी किसी ट्रायंगल में कोई एक लाइन जो एक साइड से, ट्रायंगल की किसी भी साइड से पैरेलल हो और बाकी दोनों साइड को अगर वो इंटरसेक्ट करता हो तो जो इंटरसेक्शन के बाद जो रिमेनिंग साइड्स का जो रेशियो होगा वो इक्वल होगा. सो हियर वी अंडरस्टूड द थ्योरम ऑफ बेसिक प्रोपोर्शनैलिटी एंड नाउ आई वांट टू एक्सप्लेन यू द स्टेटमेंट ऑफ कॉन्वर्स ऑफ बेसिक प्रोपोर्शनैलिटी थ्योरम. अगर इसी का भी हम लोग कन्वर्स करें तो क्या होगा? इफ अ लाइन डिवाइड्स एनी टू साइड्स ऑफ अ ट्रायंगल इन द सेम रेशियो, देन द लाइन इज पैरेलल टू द थर्ड साइड. दिस विल हेल्प यू टू सॉल्व द सम्स, सो प्लीज अंडरस्टैंड प्रॉपरली. जब भी अगर किसी ट्रायंगल में रेशियोज इक्वल होंगे तो कोई एक लाइन जब किसी ट्रायंगल को दो साइड्स में, उसके जो रिमेनिंग दो साइड्स है उसको डिवाइड कर रही है और वो भी इक्वल रेशियोज में, तो वो लाइन जो बाकी बची हुई साइड है उससे पैरेलल होगी. दैट इज व्हाट द कन्वर्स ऑफ बेसिक प्रोपोर्शनैलिटी थ्योरम. इफ अ लाइन डिवाइड्स एनी टू साइड्स ऑफ अ ट्रायंगल, इन द सेम रेशियो. सो जो हमें यहाँ पे प्रूव करना था वो यहाँ पे ऑलरेडी दे दिया है. मतलब इन द सेम रेशियो इफ इट डिवाइड्स देन द लाइन इज पैरेलल टू द थर्ड साइड. मतलब ये लाइन फिर पैरेलल होगी थर्ड साइड से. सो प्लीज रिमेंबर दिस स्टेटमेंट्स. ओके, बोथ द थ्योरम, दैट इज थ्योरम ऑफ बेसिक प्रोपोर्शनैलिटी and the statement of converse of basic proportionality theorem, as the statement is very useful for solving the sums. After understanding the concept of basic proportionality theorem and the converse of basic proportionality theorem, we are doing the sums related to that particular concept. So practice set 1.2, question number 2. यहां पे आपको ट्राइंगल दिया हुआ है. In triangle PQR, PM is equal to 15. You can see here the PM is equal to 15, PQ is equal to 25, PR is equal to 20, and R is equal to 8. State whether line NM is parallel to side RQ. Give reason. So हमें ये फाइंड आउट करना है कि क्या लाइन NM साइड RQ से पैरेलल है, और हाँ तो उसका हमें रीजन देना है. So let's see here. Given in triangle PQR, PM is equal to 15, PQ is equal to 25, PR is equal to 20, and R is equal to 8. Now what we have to find out, line NM is parallel to side RQ. हमें प्रूव करना है लाइन NM साइड RQ से पैरेलल है, सो वही हमें फाइंड आउट करना है. और अगर ये पैरेलल है तो हमें उसके रीजंस भी देने हैं. सो लेट्स स्टार्ट विद द सॉल्यूशन. Here we knows the concept that converse of basic proportionality theorem, if a line divides the two sides of a triangle in equal ratio, then that line is parallel to the third side. मतलब अगर कोई लाइन बाकी ये जो दो साइड्स है, ये दो साइड्स को अगर वो इक्वल रेशियो में डिवाइड करती है तो वो थर्ड साइड से पैरेलल है, ये हमें मालूम है. So here we can utilize the concept of converse of basic proportionality theorem. Now for that we have to prove that whether their ratios are equal or not. So for that reason हमें पहले लगेगा PM की जरूरत पड़ेगी और MQ की जरूरत पड़ेगी, and then we will show it. So let's see here. PN, we knows that PR is equal to PN plus NR, as N lies between P and R. So we can do the addition subtraction here. Now PR, we knows that it is 20, PN we have to find out, and NR we knows that this is 8. So here we can say PN is equal to 20 minus 8 is equal to 12. And now this here we found that this is 12. Similarly, we will try to find out MQ. So we knows that PQ is equal to PM plus MQ, and we knows that M lies between P and Q. So we can do the addition and subtraction. So these are the points in a single line. Now PQ is 25. PM is 15, MQ we have to find out. So 25 minus 15 is equal to MQ, therefore MQ is equal to 10. And now as if we got this here as a 10 units, we have to check that ratio. हमें अभी रेशियो फाइंड आउट करना है Pn upon Nr. So Pn is 12 and Nr is 8. So we knows that 4 2s are 8, 4 3s are 12. So 3 upon 2. Similarly, we will find out the ratio Pm upon Mq. So Pm is 15 and Mq is 10. So 5 2s are and 5 3s are. So 5 2s are 10, 5 3s are 15. Here also we are getting the ratio as 3 upon 2. So now from 1 and 2 we can say Pn upon Nr is equal to Pm upon Mq. When these two are equal, then we can say that by converse of basic proportionality theorem, these two lines means line NM is parallel to side RQ. So here we can understand that the ratios of Pn upon Nr is 3 upon 2. Ratio of Pm upon Mq is also 3 upon 2. So by the ratio we can understand N upon Nr is equal to Pm upon Mq. And if these two ratios are equal, then by converse of basic proportionality theorem, we can say that line NM is parallel to side RQ. So यहाँ पे हमने प्रूव किया कि लाइन NM साइड RQ से पैरेलल है by using converse of basic proportionality theorem. Now we are solving question number 4. Here in this triangle ABC, measure of some angles in the figure are given. You can check angle APQ is equal to 60 degree and angle ABC is also 60 degree. Prove that AP upon PB is equal to AQ upon QC. In this, here we have to prove that AP upon PB is equal to AQ upon QC. By basic proportionality theorem, if we can prove that segment PQ is parallel to segment BC, then we can say that these two ratios are equal. And for that reason, we have to prove that these two lines are parallel. So, हमें अगर बेसिक प्रोपोर्शनैलिटी थ्योरम से इन दोनों के रेशियो को प्रूव करना है, तो सबसे पहले हमें प्रूव करना पड़ेगा कि ये दोनों लाइंस पैरेलल है, और इसीलिए आपको हिंट दी गई है कि ये दोनों एंगल्स कॉन्ग्रुएंट है. सो लेट्स स्टार्ट विद द सम. In triangle ABC, angle APQ is equal to 60 degree and angle ABC is equal to 60 degree. This is given. Therefore, we can say that angle APQ is congruent to angle ABC. यहाँ पे हमने देखा कि angle APQ is congruent to angle ABC. So by corresponding angles test, we can say that segment PQ is parallel to segment BC. Why we can say? Because of corresponding angles test of two parallel lines. And now, if these two lines are parallel, then we can say that in triangle ABC, AP upon PB is equal to AQ upon QC by basic proportionality theorem. So यहाँ पे हमने जो प्रूव करना था वो हमने प्रूव किया. AP upon PB is equal to AQ upon QC. Now you understand कि हमें प्रूव क्या करना था? AP upon PB is equal to AQ upon QC. Now these ratios are of, here you can see the intersecting sides के है कि जो साइड इंटरसेक्ट हो रही है उसी साइड्स के रेशियो है. इसका मतलब हम लोग बेसिक प्रोपोर्शनैलिटी थ्योरम से इसे प्रूव कर सकते हैं. बट बेसिक प्रोपोर्शनैलिटी थ्योरम के लिए जो मेन बात है वो क्या है? तो दो लाइंस पैरेलल होनी चाहिए, इंटरसेक्टिंग लाइंस एंड द थर्ड साइड. तो यहाँ पे हमने प्रूव किया दैट सेगमेंट PQ इज पैरेलल टू सेगमेंट BC. बट हाउ? तो यूजिंग करस्पॉन्डिंग एंगल्स टेस्ट. और करस्पॉन्डिंग एंगल्स टेस्ट ये कॉन्ग्रुएंट है. करस्पॉन्डिंग एंगल्स ये हमें कैसे पता चला? तो दीज आर द मेजरमेंट्स आर गिवन टू यू, दैट इज 60 डिग्री. सो हमें यहाँ पे ऑलरेडी मेजरमेंट्स दे दिए हैं कि दोनों के 60 डिग्री है. सो यू कैन मेक अ लिंक. ओके, सो आपको ये क्यों दिया है? करस्पॉन्डिंग एंगल्स को प्रूव करने के लिए. और जब करस्पॉन्डिंग एंगल्स कॉन्ग्रुएंट है तो ये दोनों सेगमेंट पैरेलल है, और जब दोनों सेगमेंट पैरेलल है तो हम बोल सकते हैं कि किसी भी ट्राइंगल में जब दो लाइंस पैरेलल हो, मतलब एक इंटरसेक्टिंग लाइंस और थर्ड साइड, ओके, तो जो बाकी दो साइड्स है उनका रेशियो इक्वल होता है. सो हियर वी शोज दैट AP upon PB is equal to AQ upon QC. Hence we have proved. Now the next sum, which is related to the basic proportionality theorem and converse of basic proportionality theorem, is your question number 10. So यहाँ पे आप देख रहे हो, आपको एक ट्राइंगल दिया हुआ है, ट्राइंगल DEF. In the figure, X is any point in the interior of triangle. Point X is joined to vertices of triangle. See, you can see the point X is joined to the vertices of triangle. Segment PQ is parallel to segment D. You can check here, segment PQ is parallel to segment DE, and segment QR is parallel to segment EF. Fill in the blanks to prove that segment PR is parallel to segment DF. So यहाँ पे आपको already दे दिया है कि segment PQ is parallel to segment D and segment QR is parallel to segment EF, and you have to just prove that segment PR is parallel to segment DF. So let's start. This is an activity based question, so we have to fill up all the boxes. So let's see here, in the triangle XDE, you can check the triangle XDE. Okay, so this is the XDE. In this triangle, PQ is parallel to DE. PQ is parallel to DE. This is already given to you. So we will write here in the first box, given. And now, if PQ is parallel to DE, then we can understand XP. So the next part, you know, by basic proportionality theorem, these two are in the ratio. So XP upon PD is equal to XQ upon QE. So XP upon PD is equal to XQ upon QE. By basic proportionality theorem. In triangle XCF, QR is parallel to EF. So in triangle XEF, QR is parallel to EF. This is also given. As you can see, this is given to you. Segment QR is parallel to segment EF. Now, if these two segments are parallel, here we know the segment QR is parallel to segment EF, then we can say that XR upon RF is equal to XQ upon QE. So XR upon RF is equal to XQ upon QE. Same reason, basic proportionality theorem. And now you can see here it is given as from 1 and 2. So what is common in both? You can check here XQ upon QE. Okay, so this lies in both days. Okay, so we can say that the remaining part must be equal. So I can say here XP upon PD is equal to XR upon RF. And XP upon PD, you can see here XP upon PD is equal to XR upon RF. So if these two ratios are equal, then we can say that the segment PR is parallel to segment DF. किसी भी ट्राइंगल में अगर इंटरसेक्टिंग लाइन से बनने वाले जो रिमेनिंग साइड्स पे जो रेशियो है वो अगर इक्वल हो तो वो लाइन थर्ड साइड से पैरेलल होगी. एंड सो हियर we can say that segment PR is parallel to segment DE. But what is the reason? Converse of basic proportionality theorem. So here we have completed the question number 10. Thank you.